Hi! Today, we will learn about ratio and proportion. For our objectives, describe a proportion and apply the fundamental theorems of proportionality to solve problems involving proportions. What is a ratio? A ratio is a comparison of two numbers. Ratios can be written in four different ways. It can be written in phrase form, column form, division form, and fraction form. These are all read as A is to B. Now, since ratios can be expressed in fraction form, let's say in the ratio A is to B cannot be equal to 0 because if B becomes 0, it will become undefined. Ratios are expressed in simplest form. To simplify ratios to lowest terms, divide the two terms by their greatest common factor. Say for example, we have the ratio 12 is to 18, or written in column form, 12 is to 18. So in order to simplify it to lowest term, we divide the first term and the second term by their GCF. The GCF of 12 and 18 is 6. So we divide them both by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. Therefore, in simplest form, the ratio 12 is to 18 is 2 is to 3. State ratios in fraction form for the following. Write in lowest terms. Say for example, we have 5 bananas, 4 mangoes, 3 pineapples, 6 watermelons, and 8 avocados. Number 1, what is the ratio of bananas to watermelons? Since there are 5 bananas and 6 watermelons, therefore the ratio of bananas to watermelons is 5 is to 6. Next, what is the ratio of mangoes to watermelons? There are 4 mangoes and 6 watermelons. So the ratio is 4 is to 6. But if you will try to observe, we can still simplify this ratio. And in simplest form, this is equal to 2 is to 3. Next, what is the ratio of pineapples to watermelons? In the given, there are 3 pineapples and 6 watermelons. Therefore, the ratio is 3 is to 6, or in simplest form, this is equal to 1 is to 2. Next, what is the ratio of mangoes to bananas? The ratio of mangoes to bananas is 4 is to 5. Next, what is the ratio of avocados to all the fruits? There are 8 avocados. And what is the total number of all the fruits? The total number of all the fruits, we have 5 plus 4 plus 3 plus 6 plus 8. The total number is 26. So if you will try to observe, the ratio 8 is to 26 can still be simplified. In lowest term, this is equal to 4 is to 13. Let's have more examples of expressing ratios. Number 1, find the ratio of 14 days to 3 weeks. So we cannot immediately say that the ratio of 14 days to 3 weeks is 14 is to 3. That is wrong, since we are dealing with different units. So in order for us to express 14 days to 3 weeks in ratio, we must first convert one of them. So let's say we convert 3 weeks into days. Since there are 7 days in a week, in 3 weeks there are 21 days. So the ratio now becomes 14 days to 21 days. We are now dealing with same unit. So we have 14 is to 21. If you will try to observe, we can still simplify this. Both 14 and 21 can be divided by their GCF, which is 7. So if we divide 14 by 7, we get 2. If we divide 21 by 7, we get 3. Therefore, the ratio in simplest form of 14 days to 3 weeks is 2:3. Let's have another example. Find the ratio of 300 centimeters to 7 meters. Remember that in 1 meter, there are 100 centimeters. So if we have here 7 meters, this is equivalent to 700 centimeters. So we now have the ratio 300 centimeters is to 700 centimeters. We can still simplify this ratio by dividing 300 and 700 by their GCF, which is 100. 300 divided by 100 is 3. 700 divided by 100 is 7. Therefore, the ratio of 300 centimeters to 7 meters is 3:7. Let's have example number 3. If the measure of angle A is 30 degrees and the measure of angle B is 90 degrees, find the ratio of the measure of angle A to the measure of angle B. The measure of angle A is 30 degrees. The measure of angle B is 90 degrees. Therefore, we have the ratio 30:90. We can still simplify by dividing 30 and 90 by their GCF. Their greatest common factor is 30. 30 divided by 30 is 1. 90 divided by 30 is 3. Therefore, the ratio of the measure of angle A to the measure of angle B is 1:3. Let's have the fourth example. The perimeter of a triangle is 60 centimeters. The measure of the sides is in the ratio 3:4:5. What is the measure of each side? So say for example, the measure of the first side is 3x. The measure of the second side is 4x, and the measure of the third side is 5x. It says in the problem that the perimeter is equal to 60. So if we get the sum of 3x, 4x, and 5x, the sum must be equal to 60. Now, adding 3x, 4x, and 5x, we get a sum of 12x. So we have 12x is equal to 60. Find the value of x, divide both sides by 12. Therefore, x is equal to 5. Now, we can solve for the length of each side. For the first side, we have 3 times 5. Second side, we have 4 times 5. Third side, we have 5 times 5. Therefore, the measure of the first side is 15 centimeters. Second side, we have 20 centimeters. And the third side of the triangle measures 25 centimeters. Let us now proceed to proportion. What is a proportion? Proportion is the equality of two ratios. If A is to B and C is to D are ratios, then A is to B is equal to C is to D are proportions. It can also be written this way in column form. So let's say we have, so when we say proportion, it only means we have two equal ratios. So as simple as that. So let's say we have the ratios A is to B and C is to D. So if the ratio A is to B is equal to C is to D, then it forms a proportion. Now in the proportion A is to B is equal to C is to D, the second and third term are what we refer to as the means, while the first and fourth term are what we refer to as the extremes. So say for example, we have the proportion 3:2 is equal to 6 is to 4. Now, the inner terms, or the second and third term, are the means, 2 and 6, while the first and fourth term, or the outer terms, 3 and 4, are the extremes. If we write each ratio in fraction form, 3 is to 2 is equal to 6 is to 4, 3 and 4, these are our extremes, while 2 and 6 are the means. Law of proportion. The law of proportion states that the product of the means is equal to the product of the extremes. Say, for example, we have 5 is to 10 is equal to 3 is to 6. We know that the means are the inner terms, or 10 and 3 are the means, while the outer terms, or 5 and 6, are the extremes. So if we get the product of the means, we have 10 times 3, we have 30. If we get the product of the extremes, 5 times 6, that is also equal to 30. So if the product of the means is equal to the product of the extremes, then the two ratios form a proportion. Are the following proportions, yes or no? So in order for us to determine if each pair of ratios form proportion, we will apply the law of proportion. Again, the law of proportion states that the product of the means is equal to the product of the extremes. For number 1, we have 4 is to 2 and 7 is to 13. The product of the means, 2 times 7 is 14. The product of the extremes, 4 times 13 is equal to 52. Since the product of the means is not equal to the product of the extremes, therefore, they do not form a proportion. So the answer is no, it is not a proportion. Number 2, 6 is to 15 and 2 is to 5. The product of the means, 15 times 2 is 30. The product of the extreme, 6 times 5 is also 30. Since the product of the means is equal to the product of the extremes, therefore, yes, it forms a proportion. Number 3, 5 is to 4 and 12 is to 6. What is the product of the means? 4 times 12, 48. 6 times 5, 30. Therefore, the answer is no, it is not a proportion. Number 4, 6 times 8, 48. 16 times 3, also 48. Yes, it forms a proportion. Number 5, product of the means, 4 and 15. We have 60. Product of the extremes, 12 times 5 is also 60. Therefore, yes, it forms a proportion. The law of proportion is used to find the missing term in a proportion. So solve to find the missing term. Number 1, 10 is to 5 is equal to 20 is to blank. Let us rewrite each ratio in fraction form. So we have 10 is to 5 is equal to 20 is to, let's say the missing term is x. So what we're going to do is we will apply the law of proportion. The product of the means must be equal to the product of the extreme. So by cross multiplication or cross product property, 10 times x is 10x, 20 times 5 is 100. To solve for x, divide both sides by 10. Therefore, x is equal to 100 divided by 10 is 10. Therefore, the missing term in the given proportion is 10. Number 2, 10 is to blank is equal to 1 is to 3. Rewrite in fraction form, we have 10 is to, let's say x is the missing term, is equal to 1 is to 3. the product of the means is equal to the product of the extremes. So x times 1, x. 10 times 3, 30. Therefore, the value of the missing term is 30. Number 3, 5 is to 4 is equal to 10 is to x. Cross multiply, we have 5x is equal to 4 times 10, 40. Divide both sides by 5. Therefore, x is equal to 40 divided by 5 is equal to 8. So, the missing term in the given proportion is 8. Number 4, blank is to 6 is equal to 8 is to 3. Let's say x is the missing term. X is to 6 is equal to 8 is to 3. 3 times x is 3x. 8 times 6 is equal to 48. Divide both sides by 3. Therefore, x is equal to 48 divided by 3 is equal to 16. So, the missing term is 16. Number 5, 5 is to 2 is equal to blank is to 12. 5 is to 2 is equal to x is to 12. Cross multiply, 2 times x is 2x. 5 times 12 is 60. Divide both sides by 2. Therefore, x is equal to 60 divided by 2, 30. So, the missing term in the given proportion is 30. So, that is how we solve for the missing term in a given proportion. We simply apply the law of proportion, which states that the product of the means is equal to the product of the extremes. Let's have more examples. Find the fourth proportional to 3, 4, and 9. In this given problem, we are asked to find the fourth term in the given proportion. So, our proportion will be 3 is to 4 is equal to 9 is to x. By cross product property, so we have 3 times x is 3x, 9 times 4 is 36. Divide both sides by 3. Therefore, x is equal to 36 divided by 3 is 12. So, the fourth proportional is 12. Next, find the mean proportional between 4 and 16. For our solution, the extremes are given. So, in this given problem, 4 and 16 are our extremes, or the first and the fourth term. And the unknown are the means. So, if we are to write our proportion, we have 4 is to x is equal to x is to 16. If we cross multiply, we have x times x squared, 4 times 16, 64. To solve for x, we extract the square root. Square root of x squared is x, and the square root of 64 is 8. So therefore, the mean proportional between 4 and 16 is 8. So therefore, we have the proportion 4 is to 8 is equal to 8 is to 16. Or in fraction form, we have 4 is to 8 is equal to 8 is to 16. Okay, let's have the third problem. Solve for x in the proportion 12 minus x is to x is equal to 16 is to 8. In order for us to solve for x, we simply cross multiply. So we multiply 8 by 12 minus x, and then 16 times x is 16x. By distributive property, 8 times 12 is 96. 8 times negative x is negative 8x. We have 96 is equal to 16x plus 8x. So we have 96 is equal to 16x plus 8x is 24x. To solve for x, divide both sides by 24. Therefore, x is equal to 96 divided by 24 is 4. So x is equal to 4. This time, let's have a word problem involving proportions. Rose is making hot cake for merienda. The instructions say to use 4 cups of water with 3 cups of hot cake mix. What is the ratio of hot cake mix to water? If Rose uses 12 cups of hot cake mix, what amount of water does she need? So the first question is, what is the ratio of hot cake mix to water? Since the instruction says 4 cups of water with 3 cups of hot cake mix, so for every 3 cups of hot cake mix, Rose will use 4 cups of water. Therefore, the ratio of hot cake mix to water is 3:4. Next question. If Rose uses 12 cups of hot cake mix, what amount of water does she need? So using the ratio 3:4, this is now equal to, so for every 3 cups of hot cake mix, Rose will use 4 cups of water. Now the question is, for 12 cups of hot cake mix, what amount of water will she need? So let's say that the missing term in the given proportion is x. Okay, rewrite our ratios in fraction form. 3:4 is equal to 12:x. 3x is equal to 12 times 4, 48. To solve for x, divide both sides by 3. Therefore, x is equal to 48 divided by 3 is 16. Therefore, for 12 cups of hot cake mix, Rose needs to use 16 cups of water. Fundamental theorems of proportionality. The properties that follow show several ways of rewriting proportions that do not alter the meaning of their values. So we have here cross-multiplication property, alternation property, inverse property, addition property, subtraction property, and sum property. Now we can use these properties in rewriting proportions. If we rewrite proportions by applying this property, we do not change the meaning of their values. We rewrite them, but we do not change the meaning of their values. Say for example, okay, for number 1, we have cross multiplication property. So if we have w is to x is equal to y is to z, we can rewrite it by applying cross multiplication property. It becomes wz is equal to xy. So say for example, we have the proportion a is to b is equal to 2:3. So if I will rewrite this proportion by applying cross multiplication property, we're going to have 3a is equal to 2b. So we simply multiply the means and the extremes. Number 2, we have the alternation property. So if we have w is to x is equal to y is to z, if we will rewrite it using alternation property, it becomes w is to y is equal to x is to z. If you will try to observe, we switched the means. So in our given example, a is to b is equal to 2:3. If we will rewrite it in using alternation property, it becomes a is to 2 is equal to b is to 3. So you just switch the means. Next, we have the inverse property. Let's say we have w is to x is equal to y is to z. If we will rewrite this proportion using inverse property, it becomes x is to w is equal to z is to y. So if you will try to observe, we put the value in the numerator to the denominator, and then the one in the denominator in the numerator. So in our given example, a is to b is equal to 2 is to 3. If we will rewrite it using inverse property, it becomes b is to a is equal to 3 is to 2. Next, we have the addition property. If w is to x is equal to y is to z, then w plus x is to x is equal to y plus z is to z. So if you will try to observe, you simply add the denominator in the numerator. So in our given example, a is to b is equal to 2 is to 3. If we will rewrite it using addition property, it becomes a plus b is to b is equal to 2 plus 3 is to 3, or simply 5 is to 3. Next, subtraction property. If we have w is to x is equal to y is to z, then w minus x is to x is equal to y minus z is to z. Okay, this is the same as addition property. The only difference is this time we make use of subtraction. So using our given example, a is to b is equal to 2 is to 3. If we rewrite this proportion using subtraction property, it becomes a minus b is to b is equal to 2 minus 3 is to 3, or simply negative 1 is to 3. Next, we have the sum property. So if we have u is to v is equal to w is to x is equal to y is to z, then u is to v is equal to w is to x is equal to y is to z is equal to u plus w plus y is to v plus x plus z. And that is equal to k, where k is a constant at proportionality, and v is not equal to 0, x is not equal to 0, z is not equal to 0. Let's have an example. Use the properties of proportion to complete each statement. If m is to n is equal to 10 is to 3, then number 1, 10n is equal to, this is equal to 3m. So what property did we use? So we made use of the cross product property. Next, 3 is to 10 is equal to n is to m. What did we do? We invert the proportion. In short, we made use of the inverse property. Next, m plus n is to n is equal to 10 plus 3 is to 3, or simply 13 is to 3. So we made use of the addition property. Number 4, m is to 10 is equal to n is to 3. So if you will try to observe, we switched the means. So in short, we made use here of the alternation property. Complete each statement. So in order for us to complete each statement, we will apply the properties that we have learned a while ago. Number 1, if x is to 5 is equal to 3 is to 7, then 7x is equal to 3 times 5, and that is equal to 15 by cross product property. Next, if 4 is to t is equal to 8 is to 9, then 8t is equal to, so again, by cross product property, this is 4 times 9, 36. Number 3, if x is to 4 is equal to 7 is to 3, then 3x is equal to, so still in number 3, we will use cross product property. So 3x is equal to 4 times 7, 28. Next, if x is to y is equal to 3 is to 8, then what is y is to x is equal to, so here we will use inverse property, therefore y is to x is equal to 8 is to 3. Number 5, if a is to 7 is equal to b is to 8, then what is a is to b? A is to b is equal to 7 is to 8. In number 5, we switched the means. A is to b is equal to 7 is to 8. Solving problems involving proportion. Example number 1. If m is to n is equal to 5 is to 4, find 4m minus 2n is to 4m plus n. For our solution, first, the given proportion, let us rewrite it in fraction form. So we have m is to n is equal to 5 is to 4. By cross product property, we have 4m is equal to 5n. If we solve for the value of m, divide both sides by 4. Therefore, m is equal to 5n over 4. Now, we will use this value of m, 5n over 4, in the given ratio 4m minus 2n is to 4m plus n. In fraction form, this is 4m minus 2n is to 4m plus n. Now we will substitute 5n over 4 to m. So we have 5n over 4 minus 2n all over 4 times, again the value of m is 5n over 4 plus n. If we look for possible cancellations, 4 will be cancelled here. So what will happen? We will have 5n minus 2n over 5n plus n. Combine like terms, so we have 5n minus 2n, we have 3n is to 6n. If we simplify, n can be cancelled, so we only have 3 is to 6, so simplify 3 is to 6, so we have 1 is to 2. Therefore, for our final answer, 4m minus 2n is to 4m plus n. It is equal to 1 is to 2. Example number 2. If w and z represent two non-zero numbers, find the ratio w is to z of 3w squared plus wz minus 4z squared is equal to 0. So for our solution, the first thing that we need to do is to factor the trinomial 3w squared plus wz minus 4z squared. Okay, so we're going to have 3w plus 4z and w minus z. By zero product property, we have 3w plus 4z is equal to 0, and w minus z is equal to 0. 3w is equal to negative 4z. To get the ratio w is to z, we divide both sides by 3z. So therefore, on the left side, we have w is to z, and that is equal to, and while on the right side, z can be cancelled, so we have negative 4 is to 3. Here, we are going to have w is equal to z. Divide both sides by z to get the ratio w is to z. And then z over z is the same as or equal to 1 is to 1. So therefore, the ratio w is to z is equal to negative 4 is to 3 or 1 is to 1. Example number 3. If R, S, and T represent three positive numbers such that R is to S is to T is equal to 4 is to 3 is to 2, and R squared minus S squared minus T squared is equal to 27, find the values of R, S, and T. So for our solution, let us first have, so we have R is to S is to T is equal to 4 is to 3 is to 2. So we can write this as R is to 4 is equal to S is to 3 is equal to T is to 2 is equal to K, where K is not equal to 0. So each we will equate to K. R is to 4 is equal to K. S is to 3 is equal to K. And then T is to 2 is equal to K. Now solve for R, S, and T. By cross product property, R is equal to 4K. By cross product property, S is equal to 3K. And by cross product property, T is equal to 2K. Now we will use these values and we will substitute them in the given equation. R squared minus S squared minus T squared is equal to 27. So R, we have the value 4K. Substitute 4K to R. Substitute 3K to S. And substitute 2K to T. Oh, sorry, this is 27. Now let us simplify. 4K squared is 16K squared. 3K squared is 9K squared. And 2K squared is 4K squared. Combine like terms, 16K squared minus 9K squared minus 4K squared, that will give us 3K squared is equal to 27. To solve for K, divide both sides by 3. So we have K squared is equal to 9. Now extract the square root. K is equal to, the square root of 9 is positive 3 and negative 3. But in this case, we will disregard negative 3 because as given in the problem, we are looking for the values of R, S, and T, which are positive numbers. So we will only consider positive 3 for k. Now that we have the value of k, which is 3, we will substitute this. Since r is equal to 4k, so we have 4 times the value of k, which is 3. Therefore, r is equal to 4 times 3, 12. Next, we have s. S is equal to 3k. 3 times 3, that is equal to 9. Therefore, s is equal to 9. And then for t is equal to 2k. 2 times 3 is equal to 6. Therefore, the value of t is 6. So for our final answer, r is equal to 12, s is equal to 9, and t is equal to 6. Example number 4. If c is to d is equal to 5 is to 3, find the value of c squared minus d squared is to c squared minus 2d squared. First, let us rewrite this in fraction form. So we're going to have c is to d is equal to 5 is to 3. We can also rewrite this given proportion using alternation property or switching of the means. So this is also the same as c is to 5 is equal to d is to 3, and this is equal to k. So let us equate each of them to k. C is to 5 is equal to k, and d is to 3 is equal to k. By cross product property, c is equal to 5k, and d is equal to 3k. Now, in the given proportion or given ratio, c squared minus d squared is to c squared minus 2d squared. We can substitute 5k to c and 3k to d. So c squared, we have 5k squared, and then for d, we have 3k squared over, again, c is 5k raised to the second power minus 2 times d is 3k raised to the second power. Simplify, 5k raised to the second power is 25k squared. 3k squared is 9k squared over 5k squared, again, is 25k squared minus 2 times 3k squared is 9k squared. So we now have 25k squared minus 9k squared over 25k squared minus 2 times 9, 18k squared. 25k squared minus 9k squared, that is equal to 16k squared over 25k squared minus 18k squared, that is equal to 7k squared. We can cancel k squared in the numerator and denominator. So we only have 16 is to 7. Therefore, for our final answer, the value of c squared minus d squared is to c squared minus 2d squared is 16 is to 7. Example number 5. If a is to b is to c is equal to 5 is to 2 is to 3, where a, b, and c are greater than 0, find the values of a, b, and c when a squared minus b squared minus c squared is equal to 48. So first we have a is to b is to c is equal to 5 is to 2 is to 3. Therefore, we have a is to 5 is equal to b is to 2 is equal to c is to 3 is equal to k. So equate each of them to k. We have a is to 5 is equal to k, b is to 2 is equal to k, and c is to 3 is equal to k. By cross product property, a is equal to 5k, b is equal to 2k, and c is equal to 3k. Now in the given, a squared minus b squared minus c squared is equal to 48. We will substitute 5k to a, 2k to b, and substitute 3k to c. So this is 5k raised to the second power minus 2k raised to the second power minus 3k raised to the second power is equal to 48. Let us simplify. Quantity 5k to the second power is 25k squared. 2k squared is 4k squared. And 3k squared is 9k squared is equal to 48. Now what is 25k squared minus 4k squared minus 9k squared? That will give us 12k squared is equal to 48. Now divide both sides by 12. Therefore, k squared is equal to 48 divided by 12 is 4. Extract the square root. K is equal to positive 2 and negative 2. But we will disregard negative 2 since it is given in the problem that a, b, and c are greater than 0. They must be positive numbers. Therefore, k here is equal to 2. We disregard negative 2. Now that we have a value for k, we can substitute that in solving for a, b, and c. Since a is equal to 5k, substitute 2 to k, so this is equal to 10. Therefore, a is equal to 10. For b, we have 2k. So 2 times 2, therefore b is equal to 4. And then for c, c is equal to 3k. Substitute 2 to k, so 3 times 2 is 6. Therefore, these are the values of a, b, and c. A is equal to 10, b is equal to 4, and c is equal to 6. Thank you very much for listening. God bless you.